All right. So, as we said, in this class, we will cover quiz 1 of 2024. That is Math 1100. And now we're going to look at these questions that are here. So question 1 says, given that A and B are two non-empty subsets of the universal set, which is U, the universal set U, then they're telling us to just express this here, which is A complement union B minus A, then closed there and complement. So I must simplify this now, saying in the simplest form using the laws of algebra. So how am I going to do this? So using the laws of algebra, I can actually even rewrite what is inside first. So I can see that this is complement union. By definition, this set difference can be written as B intersect A complement, close there, then I have my complement. Okay, so complement can be distributed. So I can distribute this complement. And I know that where there's a complement, multiplying with another complement, this just gives me the original set, which would be A. So now complement by that complement will give me A. Then this sign by De Morgan's law is going to change from union to intersection. Then now, what is going to be that inside? So I have B here, intersect A, complement, then I'll have the complement there. So now from here, I can distribute that complement again inside there, such that I have B complement, then the sign changes from intersection to union now, then I'll have A complement there, just becomes a set A like this. So I have this here. Okay, so now how can I work out this? So how can I work out this? So if you separate them, so look here when you multiply, or not multiply, when you distribute, you say A intersect B complement like this. Using distribution, you have union, then you have A intersect what? A. So already this side, you know, A intersect A is what? Is A. The intersect A. Then what is B intersect B complement? That one we can easily see from the diagram. So let's draw a Venn diagram here. So when we draw a Venn diagram here, we have two sets, 1, 2. There's A and there's B there. Okay, so my definition, B complement means everything that's not in the set what? B, but sits in the universal set. So remember this E or U is the universal set. So now everything outside the set B is going to be this here, or this region here, apart from B. So I'm not shading B at all, that's B complement. Then they're telling me they're intersecting that with the set A. So which one is going to be the set A? So set A is, so intersect set A. So intersect set A, this one here. Let me use another color. So this here is set A. So now you check, where do these yellow lines and the white lines cross? So it's this section here, this section here, just this section here is where they cross. So this entire part here is where they're crossing. So we know that if they say this, we've seen it visually. It just means this part here, this same part that is crossing. Then now they are telling us union, bring it together. In short, bring all those elements that are in this part with the entire set what? The entire set A. So now, which one is the entire what? The entire set A. The entire set A. So say bring it all together. So the entire set A we know is this. This entire thing here is set what? Is set A. So this here, if I bring all these elements together like this, what am I remaining with? This blue set. What is this blue set? This blue set is just the what? The set A. So meaning this here, what we have here is just going to what? To simplify to the set A. So I have that this is going to be equal to the set A like that. All right. So this is how you do work out this question. Unless there are any questions, remember you're free to ask at any time. Okay. So now let's work out the one that follows. So they're telling us if two sets are disjoint, if A and B are disjoint subsets of the universal set, simplify. Let us simplify this. A minus B complement. So if A and B are disjoint, by definition, what that means is A intersect B is equal to the empty set, meaning these here do not intersect. So if I see that in a Venn diagram, it looks something like this. I'll have uko my set A. The other side uko my set B. So I have A and B. They do not have any common factor, so they do not intersect. Then I have the universal set like that. So now what is this here? Okay, I can simplify this to A intersect B complement, then I have the complement there. So I can distribute this complement and I'll just have A complement. This sign changes from intersection to union, then I'll have B like that. Okay, so A union B complement. So let me shade from my diagram here. Which one is my A complement? So everything that is not in the set A but sits in the universal set. So everything here, I'll shade everything apart from what? Apart from A, like that. So then they're telling me this part, everything here, A complement, this is A complement, it's everything outside what? Outside A, like that. Everything that is outside the set A. Okay, then okay, from here, that what is next? They're saying union the set B. So union set B. I can see it's just here. Union set B. I'm uniting, I mean everything here. Everything I've already shaded, which is A complement, everything that was outside A, then union set what? Union set B. So as I can see, when I unite with my set B, I just get this entire thing that is shaded. But how can I describe that thing that is shaded there? It's just going to be this here. That is how it's going to what? How it's going to be. Because you just have A complement, everything that is what? Outside A. So outside A, like this, or if you want, we can write it like this. So check out that this here, the entire thing that has remained here is the universal what? Is the universal set. So meaning, of course, our A, we have A complement, then intersect what? Intersect the universal set, which is U like that. A complement intersect the universal set. Of course, we can even write this further on. You can write it as A minus, I mean U minus A. Yeah, U minus A. Because see what remains here. So you don't end here where there's a this yellow line. No, you end here. So you can either end here or you end there. Any of them is going to be correct. Because here what has remained, this yellow thing, remember, it's the universal set. And we're just removing. So by definition, look, from the universal set, we just remove the set what? The set A. We want all elements that are going to sit in the universal set, but not in what? In set A. And that's what this describes. Okay, I don't know if there are any questions there. That's how you do that one. Anyone who's behind, feel free to ask. You can't ask now. You won't ask in that quiz, ka? You'll be no one to ask. Anyway, so let's evaluate the one that follows, saying evaluate the power I to 1003. So how are we going to do this? We can simplify this first. I know I can multiply one I since this is using lots of indices. If I have an I here, then I have another one. Say this here is going to be 1002. If they're multiplying like this, it means that we are adding the powers. So to this 1002, I'll be adding the power. This we know it's the power 1. So to be adding it gives me this. So which is the same thing I've maintained here. So now the next part, how do I do it? I can now simplify that part. Simplify that part to the 1002. 1002. So I can write this I like this, then multiply. So if I say I squared like that, I squared, then one here I have 102. So if 2 divides into this 1002, I'll get 501. This is what I'll get. So remember, 2 by 501 gives me 1002. So I haven't changed anything. Still the same. So I have I here. So, but I know that I squared is just -1. So why not just put it here? So I'll put it -1 like that. Then I have 501 like that. Okay. 501, this is an odd power. Since it's an odd power, I know always if I raise any negative value to an odd power to give me a negative value. So what this means is that I'll just get I. This side I'll still get -1. I multiply these two, and it just gives me this to be equal to negative I, like this. So this is my answer. All right. Let's go to part B. This is part B of the question. So now, what are these? What are they asking us for? So they're saying let x that's from -10 to 10 be the universal set. So our universal set is x from -10 going all the way up to 10 like that. Then our set A, our set A, I know it's not clear, but I'll say it, that's -10 going up to 6. So what this means, in the first one, these endpoints are part of this set. So where it is open, it means this -10 is not part of this set that is here. But where it is closed like this, they are part of that set. Then you have your set B just equal to 0 here, comma, 7. So this is your set. So the endpoints are square. They are square brackets, so they'll be included. And C, the set C is 4 up to +10. So here it's open both sides. We know that these will not be part of our interval. Then they just tell us, okay, be success. They're saying find the sets and illustrate the solutions on the number line. So I have A and I C like this, then intersect B. So now how am I going to find this? Let me put it into something I can actually see properly, which is A intersect C complement like this, B like that. So these things, you don't even have to stress. You first find out what this is, then intersect it with this one. So now, always, so here you can see that you have your set A, we have, our set B, we have C complement. We can easily find C complement. We have the set C here. So the set C is 4 and 4, 10. Values that are in between here are the ones that are in set C. But 4 and 10 are not in C. But if 4 and 10 are not in C, meaning these have to be in the complement. So, meaning from 4 +4 here, going up to what? What's the least value in the universal set? It's -10. So even all the way up to -10, this here is going to be part of C complement. Since we are saying the complement of a set, all values that are not in that set but belong to what? To the universal set. That would be the complement of the set. But is it just only this part? No, this is not the only part. The only part that is going to be there. I know. So this went from 4, then 10. So I look at my universal set, 10 here. So I have to unite this. Unite this with what? With the point, or with this value of what? Of 10, because 10 is in the universal set, so meaning it has to be here. So I write this as 10. That's going to contain one value. Okay, so this is how it's going to be. So this is my C complement. I have my A, I have my C complement. I can actually plot this such that I'm able to see it. And I have my B as well. So I can do this well. So now, how is this going to look? Okay, so this here is my universal set. It's going from here, -10, to that side, +10. And see, I've shaded in these two circles. It means they are included. They're part of that interval, or part of that set, I mean. So now, I can plot what is my A. My A goes from -10 to 6. So now, let's say our 6. What is our 6? Let's say our 6 is somewhere here. And our -10 is there. So A goes from here. It is open. Look, it is open at -10. Okay, I would want to use, let me use a different color for this one. So it is open here. Since it's open, it goes all the way up to what? Up to 6. And at 6, what is it? It's closed. So this is my set A. What is my set C? C what? C complement now. So C complement, the one which we're looking for. Okay? C complement is just from -10 included. So my C complement, I'll use a different color as well. C complement is from here going up to what? Up to 4. So let's say our 4 is somewhere here. So it's going to come up to there. Okay. So it's going to go up to there. So now, is this the only things that are not in the set C? No. So the other point which is in C complement is just what? The point 10, which is just there. So you indicate it like that. Then this open gap here we see from 4 to just 10, of course not included, is the set towards C. But now we're interested in C complement and not in the set C. From here, I see where do these intersect from? Where are these what? These two sets, where are they intersecting? Because here it's A intersect C complement. So I see where do they intersect? So it is this point here. So, and this point. These, they have common elements here, in between here. But now see, for the first one, A, it is open at 10. So meaning it will not intersect with that point. Since this point 10 is not in A, although it's in C complement, but it's not in A, so it won't intersect. So meaning what you have is you have it open here at 10, negative 10. It's going to be open. Then it's going all the way up to what? Up to 4. Here I can see 4 is in both of the sets. It's closed here and it's there. So meaning here it's going to be closed. This here, this set here is just the first part here. So now they are telling me to intersect this with what? With B. I need to intersect this with the set B. So let me plot it separately. So what can I do? What I can do is let me rub this. Okay, a bit small. So I'll rub this set here. So this yellow one now, this yellow remaining set of which I am editing here, is going to represent what? This set, which is the first part which we've just found. So how is it here? We said it's going to be open now. It's open like this. It's closed here. So this here is the set A intersect C complement. Now what is my set B? My set B goes from 0 to what? To 7. So if I say, okay, let my 0 be here, my 0 be here, and let my 7 be there. Okay, so from there, how is it going to look? So it is closed on both sides. So here I'll close at 0. Then I'll go all the way up to what? Up to 7, and I'll close. Okay, I've closed here. So now, what does this mean for me? So for me, this means here, where then they're intersecting. These are the common elements. So I can see they're common. And it's closed on both sides, here and there. So meaning the 0 there and the 4 are going to be included. The 0 and the 4 are going to be included. And this here is going to be the answer for A minus C, then intersect B. But they're telling me to also illustrate the solution on the number line. So even I will not just end there. So what I'll do is I'm going to plot that as well. So can plot that. So when I plot this, what am I going to have? So let me erase this part as well, and 10 there. Okay, so I plot from 0, so 0 is here, up to 4. 4 is there, it's closed on both sides. So this side and that side. So this here is going to be my A, my C, this intersect B, and you're done just like that. All right, there are no questions. Is that a question?
Question.
Yes.
So that you're supposed to write on a separate number line for the answer.
Yes, so you show the answer like this, separately after you've done the working. So the working, like the way we've done, those number lines, you also show them. It's important to show them.
Okay, thank you.
You are welcome. All right, let's do the ones that follow now. Okay, so yeah, let's do the ones that are going to follow. Okay, so the one that follows is just they're telling you B complement intersect C complement, and there's another complement.
Sorry, sir.
Yes.
I have a question.
Mm-hmm.
So, are you not supposed to start with drawing the number line before you find the values? Because me, I can't understand without the number line. I mean, if you draw a number line, then you display your values that have been given. Like A, you draw -10 to 6. You draw a comma open line on -10 and a comma closed thing on 6. So I can't understand the procedure you did.
Okay, so you're saying you want to plot all of these at first?
Yes.
Okay, it's okay even if you do that. It's okay. So you can plot just to get a graphic oasis. But for me, I don't know, we can see that if you have this set A's, and here I just brought in to do exactly with what the question is asking for, So you can actually plot them first. So I understand what you're saying. Like the way we did with CI. So if we had plotted first, like this, here it's closed, -10, and there you have 10. Right? So if we had plotted C first, so C is from 4 to 10, 10 like this. So here it will be open, all the way that side to be open. So now the way we're finding it, here where we found C complement, the only way now, since you have this one, you'll be able to see it is, oh, C complement means it's going to be from here, going what? This side closed,
with
and
-10.
yes, that side there, this side here, since it was open there. And so you can
So
actually,
you're not
no,
supposed to go the other side
which other side?
on +10. If there are no values, just remain there.
Yes. So because our universal set has finished here.
Or
Okay. So you can do it like that. All right. This if the oasis guys closes, just join using the same link. Right?
okay.
Right. So you can just mute your mic just that we continue. All right. So let's continue now. So we have A complement intersect C complement complement. This one here is actually becoming is because this complement I can distribute, and I know I'll have B. This sign changes from intersection to union, and the C there become there. So I have B union C. So I just plot my B and my C, and I unite them. So if you see here, we go from -10, and this other side +10. So what is my B? My B is going from 0. So let's say my 0 is somewhere here, and my 7 is somewhere there. So it goes from here, it's closed here, all the way up to 7 there, it's closed. Then what is going to be my C? My C is open at 4. So let's say our 4 is here. So it's open here at 4, and it is open at what? Open at 10. And they're telling me to unite all these points together. It's just bringing them together. So I'll start from this yellow one here. It is closed at this yellow one, right? So since it's closed, so meaning 0 is going to be part of there. Then on this other side here, it is open at 10. So I'll get that to be open here at 10 like this. So this is what I get to be my B union C. And after you've done this, you can even plot it on its own, which you know is just going to be a straight line. If you have from here, -10 there, then you have this going up to 10, then you just have from 0 here towards to 10. So 0 towards to 10, open like that. Yeah. So this is how it's going to, this is just the solution, like the final answer. But the working is this one here. This shows you like when you unite everything. All right. So next one now. So you see, if you just know the set laws, these things become easy. You have A intersect C complement. So this one we can take different approaches where we distribute. But if you distribute this one, it's going to be long. So what you do, just say from there, okay, I have here -10, there I have 10, like that. Then let me plot my A and my C, then I intersect them. So my A goes from what? Open, it's open here at 10, and it goes up to 6. So let's say it goes all the way there, and at 6 it's close. So this is the set A. Then which one is my set B? So set B, no, set C, we're not in set C. So set C is 4 to what? To 10. So if say 4 is here, so it is open at 4, and it is also open at 10. Then they tell you intersect. Where do these intersect? So they intersect here and there. So they intersect. But now we see here it is open here, meaning 4 is not in what? Is not in the set C. So if 4 is not in the set C, meaning that is going to be open at 4. Then it goes up to what? 6. And here 6 is in both of the sets. So 6, it's going to be closed at 6. This here you found is your A intersect C. So now after finding your A intersect C, then you can find your what? Your A intersect C complement, meaning everything that will be outside that set there is going, and sits in the universal set is going to be in the complement. So now look at this. Let me plot this one, the answer we found. -10, then it goes up to +10. Okay, so after getting that, what then next do I do? 4. So if you have your 4 here, you have your 6 there. So it is open here and it is closed there. So now my complement, which one is going to my complement here at 4? Since 4 is not in this set which we have, meaning it will be in the complement. So here I'll close here, and it goes all the way, and here I close again. So and there, so here since it is what 6 is in that set, meaning it won't be in the complement. So it will be open here, and it will go there, and it will be closed there. So this carried one here, but we've done. This is our C intersect A intersect C complement. And I can see from there that this is just here closed at -10, going like that. Then at 4, it is closed as well. Then union, because I've just brought these two sets together. Why at 6, it's open. Then at 10, there it's what? It's closed. Then this is what you get. And if you are to plot, you already know, just putting the answer alone. Yeah, it's just the minus this part. So,
I have
like,
a question.
yes.
Why have you closed at the end of the number line where it's written -10 and where it's written +10?
Okay. So our universal set, look at our universal set is this one. It is x going from -10 to 10, meaning these points, end points, -10 and 10, are part of this universal set. They are part of the universal set. So even when I'm looking for the complement, I will say, this set, where is it going? Here, 10, I won't leave out 10 because 10 is in the universal set. By the definition of complement, it means all elements that are not in that set, but they sit in the universal set. So I see that 10 sits in the universal set, and it's not in this set here. So meaning it will be part of the complement of what? Of this set which I'm looking for here, which is A intersect C complement. That's why we include those endpoints there. But if it was open, if it was like this, if the universal set was like this, would have left it what? Open at these endpoints. We would have not closed it. It would have been open. Now that it is closed, we also close. Yeah, I think that one is clear, unless there's any question.
No, it's clear.
Okay, thank you very much. All right, let's move on.
I've got
Yeah.
a
You can ask.
yeah. So I've seen a question whereby they'll tell you to illustrate this question like on a number line and display. So how do we display?
Okay, they're telling you to what first?
Like to illustrate to illustrate the solutions on the number line and display. So
Okay.
how do we display?
It's just the same thing. It's just the language that they're actually using here. So illustrating is this. You see, the same thing. And again, displaying is still this, like you're writing it out like this. So just one and the same language they're kind of using there. So to find the following, like this here, it says find the following sets and illustrate the solutions on the number line. So you can find like this, then illustrate like that. That's what they're asking for. So illustrating, even the way English there is just the same. Illustrating and displaying are just one and the same thing. So you just work it out and display like this or illustrate like this. Okay, is there any other question before we move on to the next part? Okay, let's move on. There's no question. So those that have been attending those classes, we have this question here. They are telling us this first one. Simplify this. And they are saying live in the form P root Q, where P is ration. If you've seen this one, this video is going to cut in the next 1 minute. So just rejoin. Yeah. So if you see this one in the tutorial sheets, your tutorial sheet, this is actually swapped. There's 12 like this, and what is there is should be like something like this. Root 48 comes first, then the 1 over root 27 is the one which follows. It's like this. So it's important to solve the tutorial sheet questions, because even this one, I think they picked it out of last year's tutorial sheet question. So even you, if you've not seen those videos, check them out. Important, and just find time to solve on your own. So let's do this now. Let's do this one which is here. Yeah. So now they're telling me to express that. So I have 1 over root 12 plus 1 over root 27, then minus 1 over root 48. So in the form p root 3, where p is rational. If p is rational, it means it can be expressed in the form a over b, where b is not equal to 0. So this is what it means to be what? To be rational. Now, from here, what are we? So now we are saying we have to simplify this one, but put it in this form, where you have a root of 3 involved. So first step is try to get a root of 3 in this. So how do we do that now? We have 1 over this root, this is root 12. Root 12 can be written as 4 by 3. So I have a 3 there already secured. This one, I can write it as what? As 9 by 3. Secured. The other one, I can write it as root. This is root 16 by 3. Am I right? Hmm? Yes, it is 16 by 3. Confirm. Don't just be watching. Yeah, I can be writing wrong things. So yes, it's what? It's 16. Then from there now, let's simplify that. So that is going to be equal to what? So meaning there I can have root 4. Did I start recording? Okay, yes. So I can have root 4. Then there I'll have root 3. Can write them like that since it's a product. Then I have 1 over here root 9. Then I have root 3. Then I have minus 1 over root 16. Then here root 3. Okay, from there, what can I do next? I can evaluate this root 4, which is just 2. I have 3 there plus 1 over 3 root 3. Okay, minus 1 here 16, it's 4 root 3. Okay, now after getting this, what can I simplify it? So I have to make this first into a single fraction. So how am I going to do that? I have to get a common denominator. So what's the common denominator for this? So I know if I multiply, if I have root what? Root 12, is it? No, 12 root 3. 12 root 3. So 12 root 3 here is going to be a common denominator. Such that if I multiply this, if I divide this 2 into this 12 root 3, this root 2 root 3 divided into this 12 root 3, I'll just get 6. So 6 multiplied by this one gives me 6. Then here I divide, I'll get what? I'll get 4. So this will be plus 4. The other one there, I'll get 3. So this is minus 3. Okay. Then from here, when I subtract here I'll get 1. 1 plus 6 gives me 7. So I have 7, then root. I have 12 root 3. Okay, from here, it has not ended. I can actually continue.
Wait,
Yes.
sir,
Mm-hmm.
where is it home from?
Okay, so remember here, look at this side, this part. We are making this into a single what? Fraction. So to make it into a single fraction, we look for the common denominator. But we know that since this is even, so we don't even focus on 2 here. Just focus on the 3 and the 4. What is the common denominator for this? It's going to be what? 12. And they all have root 3, of course. And we know that 2 divides into what? Into this 12. So that's how we get the root 3. So that's our common denominator. Then you start doing you guys know how to make into a single fraction. So that's how you get it. Then here we just subtract on top. From here, what we want is, we want to get a form p root 3. It means that our root 3 must be on top and not down where it is there. So what I can do is I can multiply by root 3 both in the numerator and in the denominator. So if I multiply here root 3, I multiply there root 3. What am I going to have? So from here I'll just have on top, this will be 7 root 3. Then down there I'm going to have this root 3 by root 3 will give me 3. Then I'll just have 12 multiplied by 3. Okay, from here, how can I simplify that? So 3, what is 3 by 12? 3 by 12 is just going to give me 36. So here I have 7 over 36. Then I have my root 3 there. So it is in the form P is here. P is this here, which is 7 over 36. Can I reduce 7 over 36? No, I can't. Because it's irreducible. They have no common factors. So it qualifies to be a rational number. It's in the form P over Q. And I know this 36 is not 0. So this will be defined. And they have the root 3. So I've worked out. And that's how this one ends. Okay. What next? What next? What next here? Is the question?
There were with 7 over 12 to the root 3. And you're supposed to rationalize by multiplying by its conjugate.
Okay. So here where you have 12 root 3. So when you have this case where you just have 12 root 3, a conjugate, like you are not required to assist. You want to make free of this root, like you want to make the root free of it. So now remember what a conjugate is. It's just going to be, for example, if I have a number like the next example which we have here, we have root 3 minus 1. The conjugate of this is going to be root 3 plus 1. The sign there changes. The sign here is what changes. But now in this case, I do not have any number here. It's just 0. So meaning to make free of this, I just multiply by what? The actual root here. So if you observe, if you multiply by, if you say you are to multiply by, okay. Oh yeah, so this is, yeah, exactly. So this is how you would get it. So you just have to make free of that root. Your focus when you have a single number like this one is to get rid of what? Of the root. But when you have numbers like this, you multiply by the conjugate, you change the sign there. Okay. I don't know if that one is clear.
Sam.
Mm-hmm.
So I remember that I solved this question and then my answer is kind of like different from yours.
Okay, what's the answer?
So my answer is 5 over 12 and then square root of 3.
Okay, so 5 over 12.
And then the square root of 3.
Okay. This one, was it the same one here or the one in the tutorial sheet?
It's the one on the tutorial. It is the same one as this one.
No, they're actually different with this sign here. So, but so this one here is for the one in the tutorial sheets is the one which I talked about first. The one which is negative is 1 over root 27. Then you have plus here, then 1 over should be a 1 over root 48. Yeah, that's how they are different. But you are not supposed to get a 12 there. You're supposed to be getting a 36. Either ways, this here has to be a 36. So there's somewhere where it is not happening rightly. So just try to compute it again. You get 5 over 36 root 3.
All right.
Okay. So that's how you do it when you're just making it feel like that. So now let's do, I think you understand it better when we do this next one. The one who was asking that question. So you have that, you have 3 minus 2 root 3 divided by root 3 minus 1. Then they're telling you to put it in that form. So here now you use the conjugate concept. You are going to multiply by root 3 plus 1, then here as well by root 3 plus 1. So what does that mean? It means I multiply this 3 by that. So I have 3 root 3 here on top. Then I have 3 multiplied by 1, that will be plus 3. Then this negative by this here. So I'll just have negative 2. The root 3 cancel, then I'll remain with 3. So this here gives me what? Gives me negative 6. Then I multiply the last part, which is negative 2 root 3 is what I'll get. Then down there, this root 3 will just give me what? Remain with 3. Then I multiply. So you see, when you multiply this by that there, you get positive root 3, but multiply this by that, you get negative root 3. So that will cancel out, gives you a 0. Then you have this negative 1 multiplied by negative 1 is just going to give you what? It's going to give you a negative 1. So in short, what this means is down there, when you're multiplying with the conjugate, what you can be doing is, if you have root 3 like this, just get the root 3 there, then you square it, minus, then you square the 1 like this. So on top there, let's work out. So we can add this one and this. There are common factors I can add. So 3 minus 2 gives me 1. And I'll remain with the root 3. Then here, I can subtract as well. 3 minus 6 gives me what? Minus 3. Then down there, when I square this, I'll remain with 3. When I square that, I'll remain with 1. So this here gives me this. Then this here is just going to be root 3 minus 3. Then I have 2 there. So from here, what am I going to get? I can write this. So see that this is the same as negative 3 plus root 3, then divided by 2. So that's 2 there. I can divide it further. Just doesn't end there. I can actually divide it further. So that 2 can be divided into the 3. I have this here. Then I have plus, in front of this root 3, there's a 1. So I can divide that by like that. Then I have root 3. So my P and Q, they are saying they should be rational numbers. Agree with me. These are rational numbers that I, and I have my root 3 there, just like that. And you end here. You've what? You've solved, and you've gotten your 3 marks like that. Okay, unless there's any question here. So when you have it like this, you just simplify by rationalizing this. You rationalize. How do you rationalize? Multiply by the conjugate of that value, both in the denominator and in the numerator. All right. So let's do the next one. So the next one, they are telling you to express this. Yes.
I've got a question.
Mm-hmm.
So, like, from our tutorial sheet, question 12, like, it was asking about rationalizing the denominator. So,
Mm-hmm.
in a case whereby the denominator has a square root of 2, how do we like do the conjugate?
So the denominator only has square root of 2 like this.
No, like, okay, let me give you an example. So it's 1 divided by,
Mm-hmm.
open bracket,
Mm-hmm.
3 minus square root of 2,
Mm-hmm.
close,
Mm-hmm.
and then top.
Squared like this.
Yes.
Okay. So what you do in this case, you first, this here, what that means down there, it is 3 minus root 2 squared, means you are multiplying it to by itself like that. So work out this. 3 by 3 gives you what? 9. 3 by that one gives you negative 3 root 2 like that. Okay. Then this one here by this one gives you what? Same, negative 3 root 2. This by that there gives you plus the 2 here. This root cancels like that, and you remain with 2 like that. Then here you have this 2 and this the 9 and the 2, you can add them. It gives you what? 11. You add this here, it gives you negative 6 root 2. So what you have in your denominator, is just 11 minus 6 root 2. Then now you rationalize this. How do you rationalize? You multiply by the conjugate. So conjugate there to be 11, instead of minus it will be plus. Then you have 6 root 2. Then there you have 11 plus 6 root 2. Okay, from there, what do I get? On top, I still have 11 plus, since it's multiplying by 1, 6 root 2. Then down there, what am I going to do? I'm just square this, then minus. You have, so 6 root 2, then you square it. Okay, so what does that give you down there? So you just have here 11, you have plus 6 root 2, then you get 11 by 11 gives you a should be 1 to 1, right? Then minus. Here, this square distributes, you have it here. So this here, where we have this, the square will distribute this 2 multiplied by, squared here to be 36. Then with this 2 like that, it would cancel and you have multiplied by 2. What is the multiplication of these 2 here? This should give you 72. Then you have 72 there. So now, what is 121 minus 72? It gives you 49. So you have 11 plus 6 root 2 divided by 49. So that's what you get. So now, after getting that 49, what are you going to do? So there, you just divide your 11 divided by 49 plus 6 divided by 49, then root 2. Then you'd have expressed in this form which they are asking for. Is that clear?
Yes, thank you.
Sure, you're welcome. Now, I don't know if we're going to manage to finish, but let's do this last one for now. So we'll finish this one. In the next class we'll have. Okay, so this one, they're telling you to express in the form P over Q, where P and Q are what? Are integers. This paper was nice. Actually, the paper that if you follow the tutorial sheet, you'll be able to solve all these. You have solved the tutorial sheet, you can solve because some of these are coming from the tutorial sheet. Some they're just changing a bit. So the first thing you do here, you say I'll let my x maybe be equal to this here, this number. They need to be 0, 2, 1, 6, and you have your bar there. So here, that bar means that is the repeating units. That's what is reoccurring. 2, 1, 6, 2, 1, 6, 2, 1, 6, 2, 1, 6, up to infinity like that. So now, how am I going to do next here? What I have to do next is to make sure that that decimal point is just before the reoccurring part. So now how do I do that? I'll multiply this by 10 to move this decimal point here. I want it to move here. That's that it's just before these numbers here that are reoccurring. So here I multiply by 10 on both sides. So if I multiply 10 here, I have 10x. This other side I have 0.216 and the bar. Then from there, what you want to do, remember that number is 0.216. So you want to make sure that you move your decimal strategically. Just that if it moves, then when it moves, these other numbers, if you're able to do a subtraction, which you will do, they will cancel out. Then that repeating part will stop. So now from here, I have to move them. That means I have to move this how many times? 3 times. So 1, 2, 3. Such that it's there. So okay, from there, how do I move? I have to multiply by 1000. So if I multiply this side by 1000, where there's 10x, I'll just have 10 pin, 10,000 like that. Then this side here, how am I going to do this one? This one, after I multiply, what I'll get is 216 point. Then it continues the 126 bar like that. Then now I subtract this part where there's the bar, because I know, look here, if you subtract these two parts, they'll cancel out completely. So here you can say your 10,000x minus 10x should be equal then you have your bar like that. Okay, then this minus, you subtract the 0.216 and your bar. So now from here, what are you going to get? So subtract this side here. When you subtract 10,000 in my 10 pin x's, I just remove 10 x's from here. What am I going to get? I remain with 9,990 x's. Then this side, this part, you see, kaboom, it goes. You have your 0 minus this. And I know this is just going to give me 1,6 like that. Then I have 9,990. Then there, 9,990 like that. Then from there, you have to simplify now. So your simplification, you look for what are the common factors. Can I simplify? The question is, can you simplify this further on? So if you have 6, 1, 2, 1, 6 like this, by 90 like this, you ask yourself, can you simplify that further? Okay, I can divide by 2. It's clear. It's obvious. I think 1, 2, 6 can be divided by 2, and it gives you what? This gives you 108. Then you divide the other one by okay, it can also be divided by 2. So divide it by 2 and you have 4,995. Ask yourself, are there any other common? These, do they have any elements that are what that are common? They don't leave a remainder when I divide, should not give me what a remainder. So we try that. So we try that one. So what are you going to be getting? I can divide 3 in both of them. 3 on top, 3 down. So I'll get 36 on top. Then what do I get down there? 4,995 divided by what? By 3. You just get 1,665. Then from here, can you divide that further? I want to see. Can 3 go into both of these? Can 3 go into both of these? So I try 555. Then here, 36 divided by what? By 3. What do you get? 36 divided by 3 gives you 12. Can you go further? Ask yourself, like, can we go further here? What values can we divide into both of these? My 3 is going to into infinity. So here, 3 on top, I get 4. 3 down, I get 180. Can 2 go into 185? Okay, the same 4 go into what? 185 without leaving a remainder. No, I'm guessing it's not going to what? It's not going to go. So, meaning you end what? You end there to say, okay, I have simplified. And if you try, of which I know you don't use calculators in this course, but you try on your calculator, you punch what your 4 over 185 is. It will just give you the same recurring thing. So this here is going to be what? Our answer. All right. Do you have any questions? We are done for today.
I have a question, sir.
Mm-hmm.
So, like for these big numbers, like, do you have a trick on how we can be able to find like big numbers that can go into both the numbers without wasting much time in an exam room?
Okay. I don't know. Yeah, I don't have a trick myself, but what I do is usually these numbers you try the same. Because if you try again bigger numbers, let's say the way we had started with, you try maybe dividing by 10, it's going to be complicated. So usually start, if they are reducible, they can be reduced by very small very small numbers. Actually, like you can be simplifying it by 2, 3, 5. Usually those first small numbers are the ones that you can want to reduce by. So it will be easier that way, I think. Uh, So you can go and find the method and you come and teach us as well. We'll give you the platform. But is that clear?
Yes.
Okay. So we end here. Is everybody good?
Yes, good.
All right, all right. Okay, see you guys in the next class. We'll finish this paper in the next class.